way I've designed this is that you're always going to cook with what's called or termed a live fire. Live fire is a fire that's getting full oxygen at all times, so that that burn of the wood is a complete burn and you get that nice sweet smoke that you're after that really kisses your meat, or smoked meat at all, with a live fire. And you can control it with airflow. I actually ended up getting a patent on the unit because I have full flame control over my firebox. This area is for searing. I've put steaks here, hamburgers, and cook them for maybe a minute and 15 seconds per side, and it sears them perfect. And then you move them up into the oven, where now you've got an oven temp and you just bring them up to the temperature that you want to cook to. If you want to turbocharge that heat into there without doing anything to the fire and maintain the live fire, what you do is lower this, and it maintains a full opening here, and it actually kind of turbocharges the heat. And you can raise that temp anywhere from 75 to 150 degrees just by doing that, not touching the fire, to put more heat onto your product for a while if you wanted to. The focus is about live fire cooking, and the definition of live fire cooking is cooking with real wood and allowing all the oxygen that that fire needs to burn at a normal rate, so that you're always getting the high quality smoke. You're never starving oxygen from that fire to try and maintain control. What you're going to do is, with this lid and this smokestack, control the amount of energy that's coming from that fire into the cook chamber. You're going to peel off a certain percentage of that fire to maintain whatever heat you want. And that fire is going to burn at a normal rate. Once it locks in, it just will cruise. It's like cruise control once you've dialed in your temperature. With the fire being offset like this, as soon as it enters this cooking chamber, that heat wants to come up this front wall. So this side would be always much hotter than this side. So obviously I was after as even as I could figure out cooking footprint for everything in there. And I think I have done a pretty good job of it. And you can see here on the right side, I have what's called a heat diverter. And it's designed to be able to go up against the wall to the fire and have an opening of 1.25 inches with slots all the way across that only let so much heat through, and then let a little more heat through, but then the rest comes across the rest of it. So the footprint up here and even down in the lower is really pretty even. It's amazing. Also, this unit, as you can see, it's all stainless. It's 316 marine grade stainless, exterior 400 series stainless on the inside for a little bit better conductivity. It's also insulated with 1.5 inch ceramic blanket. Typically, you can be cooking at 400 or 500 degrees inside the oven, and it'll be maybe 80 degrees on the outside here. You can touch it and never take your hand off. It's not very warm at all. So hey, I wanted to show you guys what the ceramic blanket does as far as the insulation for the unit, and why I decided I wanted to use this. And so it makes the exterior so much cooler than any typical barbecue out there in the market. So I've got an infrared gun. It shoots and it will tell me the actual temperature. I also have a propane 500,000 BTU torch, and it's a great demonstrator of this material. What you'll also notice is that even with that kind of flame on it, it does nothing to the ceramic blanket. It can handle that kind of heat, and nothing affects it. So here we go. Take infrared reading of this side. Come on in here so you can see it. And it is 550 degrees. And on the opposite side is 69 degrees. So you can see the benefit of the insulating material. Oh, and remember, today is a burn day.